Hello all and welcome to the maths class, Standard 10, Chapter 2, Circles. Before we start today's topic, let's have a look at this. ABCD is a quadrilateral. Let's draw the bisectors of angle A and angle B. They intersect at a point. Let's mark the point. Now consider the bisector of angle B and angle C. These two lines also intersect at a point. Mark that point also. And mark the point of intersection of the bisectors of angle C and angle D, and also angle D and angle A. We get four intersecting points. Let's name them as P, Q, R and S. As seen in the picture, PQRS forms another quadrilateral. You see the circle that I have drawn. It passes exactly through the points P, Q, R and S. What if I draw a different quadrilateral? Same result. And whatever the quadrilateral is, we can see that the meeting point of the adjacent bisectors are always points on the same circle. Now let's come to our topic today, circle and quadrilateral. Continuing from my last class, I have drawn two angles in two arcs. As we have seen last time, connecting the central angles of these two angles in the two arcs, we know that each of them is half of its central angle in the opposite arc. Well, that is C by 2 plus D by 2 equals 180 degrees. Let's put it in another way. I have a circle here and I have 4 points on the circle, A, B, C, D. Joining the 4 points, I get a quadrilateral ABCD. Now, the same 4 points A, B, C and D make two angles in two opposite arcs. Let's say the angles are small a, small b, small c and small d. Consider angle B and angle D. Isn't it supplementary? Aren't they supplementary? Yes, because angles in opposite arcs are supplementary. So we have the result B plus D equals 180 degrees. In the same way, if we look at angle A and angle C, they are also in two separate opposite arcs. The sum of these two angles are also 180 degrees. We can also say A plus C equals 180 degrees. We can express this result in another way also. If all the four vertices of a quadrilateral are on a circle, its opposite angles are supplementary. A, B, C, D are points on the circle, which means that A and C are opposite vertices. B and D are opposite vertices. Angle A plus angle C will be 180 degrees. Angle B plus angle D will be 180 degrees. So, note the result once again. If all four vertices of a quadrilateral are on a circle, its opposite angles are supplementary. Now, suppose we have a quadrilateral with 3 of its vertices on the circle, but the fourth vertex is outside the circle, as shown in the picture. What about the sum of the opposite angles? Will they be supplementary? Let's check. I will draw a line from the first vertex to the point on the circle where the quadrilateral cuts the circle. Now, as we have seen earlier, A, B, C, E is a quadrilateral with 4 points on the circle, while the point D is outside the circle. According to what we have just seen about quadrilaterals with points on the with the vertices on the circle, angle A plus angle C is surely 180 degrees, and angle B plus the new angle E is 180 degrees. Now look at our angle E and angle D. Isn't angle D smaller than angle E? Yes, angle D is smaller than angle E. So that means if angle B plus angle E is 180 degrees, angle B plus angle D will be surely less than 180 degrees. Isn't that so? Now let us also consider the case where we have a quadrilateral in which the first 3 vertices are on the circle, but the 4th vertex is inside the circle, as shown in the picture. Here again we have to check if the opposite angles of this quadrilateral is supplementary. Well, let me extend one line and meet it at the circle, at a point on the circle. And also let me join the first point to that point so that I get a quadrilateral in which the 4 vertices are on the circle. Now, in this figure, surely angle A plus angle C will be 180 degrees. Now, what about angle B plus angle E? Yes, the point E is on the circle, so angle B plus angle E is supplementary. But look at our angle D. What do you think about angle D in connection with angle E? Surely angle D is larger than angle E. Well, doesn't that mean that angle B plus angle E is greater than 180 degrees? So what have we just seen now? If one vertex of a quadrilateral is outside the circle, drawn through the other 3 vertices, then the sum of the angles on this vertex and the opposite vertex is less than 180 degrees. If it is inside the circle, then the sum is more than 180 degrees. I'll repeat it. If one vertex of a quadrilateral is outside the circle, drawn through the other 3 vertices, then the sum of the angles at this vertex and the opposite vertex is less than 180 degrees. Now, if the 4th vertex is inside the circle, then the sum is more than 180 degrees. Now, suppose ABCD is a quadrilateral with angle B plus angle D is equal to 180 degrees. We shall draw a circle through A, B and C, through 3 vertices A, B and C. Will the point D be on this circle? Well, we have just studied that if the 4th vertex of a quadrilateral, if the 3 vertices are on a circle and if the 4th vertex is outside the circle, then the sum of the opposite angles, that pair of opposite angles will be less than 180 degrees. That is, angle B plus angle D should be less than 180 degrees. But that isn't so. Angle B plus angle D is equal to 180 degrees. And we have also seen the result that if 3 vertices are on the circle and if the 4th vertex comes inside the circle, then the sum of those 2 opposite angles will be greater than 180 degrees. But that is not so. Angle B plus angle D is equal to 180 degrees. So then doesn't it mean that now D is not outside the circle and also D is not inside the circle? D is neither outside the circle or inside the circle. Then that surely means that D should be on the circle. Thus we have seen that if all four vertices of a quadrilateral are on a circle, its opposite angles are supplementary. And the converse of it. If the opposite angles of a quadrilateral are supplementary, we can draw a circle passing through all four of its vertices. What we have seen here is a special kind of quadrilateral. This quadrilateral has its four vertices on the circle, and thus the sum of the opposite angles becomes supplementary. Such type of quadrilaterals have a special name. A quadrilateral for which a circle can be drawn through four vertices, we call it a cyclic quadrilateral. So children, we have just studied a new term, cyclic quadrilateral. What is a cyclic quadrilateral? What are the specialities of a cyclic quadrilateral? All the four vertices of the quadrilateral are points on a circle. We have four angles for a quadrilateral, and if it is a cyclic quadrilateral, the sum of the opposite angles is 180 degrees. Or in other words, we say opposite angles of a cyclic quadrilateral are supplementary. This is a square. It has all four sides equal and all the four angles equal. Now, a square is a quadrilateral, isn't it? Any closed figure with four sides is a quadrilateral. So, squares are quadrilaterals. Let us check if a square is cyclic. That is, let us check if a square is a cyclic quadrilateral. That is, can we draw a circle with all the four vertices of the square on it? Well, we know some of the conditions for a cyclic quadrilateral. We know that if the opposite angles of the quadrilateral are supplementary, we can draw a circle passing through all four of its vertices. Let us check if the opposite vertices of a square are supplementary. All four angles of the square are 90 degrees. Taking any two opposite angles, the sum will be 90 plus 90, 180 degrees. Take the other two opposite angles, you get the same sum. So the opposite angles of a square are supplementary, which means we can draw a circle with all the four vertices of the square on the circle. See? This is a rectangle. Well, rectangles are also quadrilaterals. Is a rectangle a cyclic quadrilateral? All we have to check is if the opposite angles are supplementary. Just like a square, a rectangle also has all its angles 90 degrees. And surely, if you add the opposite angles, you get some 180 degrees. So, rectangles are cyclic quadrilaterals too. See? Let us now think about parallelograms. Parallelograms are four-sided, so they are also quadrilaterals. Are parallelograms cyclic quadrilaterals? Squares are also parallelograms. Opposite sides are equal, opposite sides are parallel. A square is a parallelogram and a square is cyclic. Rectangles are parallelograms because the opposite sides are equal and parallel. Rectangles are cyclic. Are all parallelograms cyclic quadrilaterals? Let us take a parallelogram that's not a square or a rectangle. I have drawn in the figure. See the parallelogram that is drawn here? Check the opposite angles. What is special about the angles of a parallelogram? The opposite angles of a parallelogram are equal. Children, what do you think about the opposite angles of a parallelogram? They are equal, yes, but what do you think about their measures? Look at these two pairs. Both of them are small angles. So surely their sum is less than 180 degrees. They are both acute angles. Two acute angles always give a sum less than 180 degrees. Acute angles are less than 90. So two acute angles, sum will be less than 180 degrees. Look at the other pair, opposite pair. They are equal. Also, they are obtuse angles. Two obtuse angles surely always add up to give more than 180 degrees. So, in this case, what we have seen is the sum of the opposite angles is either less than 180 degrees or greater than 180 degrees. Both are not sufficient for cyclic quadrilateral. So parallelograms other than squares and rectangles are not cyclic. See? Next we come to trapeziums. Trapeziums are quadrilaterals in which only one pair of opposite sides are parallel. The figure shows such a trapezium. Are trapeziums cyclic? We have to observe the opposite angles. Take a close look at the figure. One pair of opposite sides of a trapezium are parallel. So we can see that angle A plus angle D is equal to 180 degrees because they are angles, interior opposite angles. Two parallel lines, a pair of opposite interior angles are supplementary. So angle A plus angle D is 180 degrees. Let us now think about angle B. Is angle A equal to angle B? The lengths of the two other sides are not the same. So surely angle A, the base angle A and the base angle B are different angles. Now we have already obtained the result that angle A plus angle D is 180 degrees. If angle A and B are not same, can angle B plus angle D be equal to 180 degrees? Surely not. Well, they are the opposite angles. Angle B and angle D are opposite angles. And if angle B plus angle D is not 180 degrees, then it's not supplementary. Thus, if angle B plus angle D will not give a sum of 180 degrees, surely the quadrilateral will not be cyclic. See? What about an isosceles trapezium? Just as we have seen earlier, we have a set of parallel lines and a set of opposite interior angles. angle A plus angle D is 180 degrees. Now let's consider angle B. What do you think about angle A and angle B? Yes, true. It's an isosceles trapezium. That means the base angles will be the same. So angle A and B are equal here. So thus, angle B plus angle D will be 180 degrees, isn't it? Now if the opposite angles of an isosceles trapezium are supplementary, then we can say that it is cyclic. Let us try to draw a circle around them. See, isosceles trapeziums are cyclic. We have now discussed about different types of cyclic quadrilaterals. A square is cyclic quadrilateral. A rectangle is also a cyclic quadrilateral. Parallelograms, which are not rectangles, are not cyclic. In trapeziums, only isosceles trapeziums are cyclic.